Welcome to the EE Smarts lesson, The Water Cycle. Let's start by looking at the pictures. They show the works of nature. Great human-made structures such as buildings, monuments, dams, bridges, and highways are modest next to the works of nature. Consider the Grand Canyon, seen in the lower left-hand corner. It was carved out of the Arizona landscape by the Colorado River. Great rivers like the Mississippi in North America, the Nile in Africa, and the Ganges in Asia have carried soils from upstream to create huge fertile deltas through the kinetic energy of moving water. Streams and rivers constantly wear away rocks and soils in one area and move sand and silt downstream. People have long observed the power of moving water and devised ways to put it to use. They have turned water's kinetic energy into mechanical energy to mill trees into lumber, grind grain into flour, and weave textiles into cloth. At Niagara Falls, pictured in the upper right-hand corner, over a century ago, they transformed water's kinetic energy into electrical energy, which has led directly to technological advances in our modern society. Where does that energy come from? We all know that gravity causes raindrops to fall from the atmosphere and causes rivers to flow from the mountains to the sea. But water at higher elevations has potential energy that is transformed to kinetic energy as it flows downhill due to gravity. How does water get to the top of the mountains in the first place? The sun lifts it. Gravity pulls the water back to Earth again, usually as rain. Where does this energy come from? Some ask the question, is the sun a pump? I'm going to make a model of what's going on here for you to see. I used the following materials: 2 plastic containers, 2 small cups, 2 packs of ice, tape, plastic wrap, a lamp with an incandescent bulb, food coloring, and water. Let me show you how I set up this activity.
To set up this experiment, I have these materials. I have 2 containers. I've already started to fill them with water. They're the same size, plastic, 2 glass bowls, some food coloring, water that I've been measuring because I need to put 500 milliliters into each container, tape, plastic wrap, and ice packs. You can use the store-bought ice packs that you put in your lunchbox or in a cooler or something, but these work fine as well. And the first thing I'm going to do is put 500 milliliters, like I said, into each container. Now I've already started it. This one has 500 milliliters. This one has 250, so I will add the last 250. So now there's 500 milliliters in each one. They're being set up the same way. All right, I'm going to take the food coloring and put a little bit in each one. Okay. We're going to swirl that around a little bit so that you can see the blue water. Okay. Now, I'm going to take the glass cup and put one in each one, just sitting it in the center. There we go. Now, each container I'm now going to cover with plastic wrap. And when I cover it, I'm going to tape it around. I'll let you see how it's done. I'll put it over the top, and I'm going to tape it around, but I want it to be a little loose so that there's a dip in the center. You don't want it really, really hot. And it gets taped around. in different spots in the cup. You try to keep in the center, so you try not to jiggle it too much. It doesn't have to be sealed all the way, you just want to get that around for less air to escape if possible. Again, you want to keep it so it's a little bit of a divot in the middle. So I'm going to tape this one, holding it down a little so that I know that that's the case. Now I'm going to do the same thing to the other container. Again, they're the same size, same amount of water in each of them. I'm going to take another sheet of Saran Wrap and put it around the same way. Again, so that you have a divot in the middle. You just want it to be a little bit loose. All right, and I'm going to tape this one around. Okay. Now we'll talk about all of this in a minute, but right now I just want you to see the setup so that you know what it is I'm doing. And again, I want to make sure there's a divot in the middle, so I'm holding that to make sure. Okay, and now in that center part, since I'm doing this inside and I want to speed it up a little bit, I'm going to use the ice pack. You could, at this point, just put a stone in this divot and sit them outside on a sunny day. Or sit one of them, I should say, outside on a sunny day. All right, I have them both with the ice pack on them. Now, one of them I'm going to move to the side. I'm going to remove it. And that one is not going to be under the light. This one, however, I'm going to turn the light on, and I'm going to let it sit like this in front of this lamp for a while, and we'll see what happens. So I'll turn it on. It would help if I plugged it in. All right, and we'll get back to it in a few minutes.
All right, looking at the setup, what is the one thing that I did different? Well, one of the containers has no light shining on it. What do you think the lamp represents in nature? If you think the sun, then you are correct. Let's look at some of the other parts of this model and what they represent. The water in the larger container represents a large body of water, such as an ocean, the Long Island Sound, or a lake. The plastic wrap represents the atmosphere that blankets Earth. The ice pack represents the cooler layers of the atmosphere, and the small cup represents dry land. Here is another view of the setup, the one that was under the lamp. Now I let them sit that way, one under the lamp and one not under the lamp, for about 30 minutes. Let's look at what happened.
All right, one of these containers has been under the lamp for about a half an hour. And what we're going to do now, I just turned the lamp off and took the ice off. I'll move that aside. And this is the one that was not under the light. I'm going to remove the plastic wrap. Any condensation that's on the underside, I'm letting some of it drip in. And I have the cup here, and I'm going to place it on a piece of paper towel. And this is the one that was under the lamp. Again, I pushed it under to get the condensation that was on the underside of the plastic wrap, and I'm going to put that on the paper towel. Now, what do you notice about the water right now? If you look here, the water is blue. You look here, the water is clear. There is water in both cups, but the water is clear. Why did that happen? Well, we'll talk about that in a moment. Let's measure the amount of water. I have these two little medicine cups so that you can see it a little bit better. I'm going to pour this into this one. This is the one that was not under the light, and this is the one that was under the light. And I want you to see that there's a significant difference with the one that was not under the light, the one on the right, your right, and the one that was under the light, the one on the left. There's a significant difference, but again, you can see how clear that is. All right, we'll talk about this in a moment.
This activity is actually a model of the water cycle. The water evaporates and turns into water vapor and goes into the air above the water in the container. It condenses under the plastic wrap. When enough droplets join together so that gravity pulls them down, they fall or precipitate, and then they accumulate in the glass cup. It models what happens in nature when water evaporates and the water vapor goes into the atmosphere, where it condenses and then falls back to Earth as precipitation where it accumulates. The picture above shows the difference between the models, one with the lamp and one without. First of all, you can see, as was pointed out in the video, that the water in the glass cups at the end of the activity was clear, unlike the blue water in the large containers. How can that be? Well, when the process of evaporation took place, only the water evaporated, not the food coloring. Even in nature, when water evaporates, the impurities in the water are left behind. The water that goes into the atmosphere is cleaner than it was on Earth. The difference in the amount of water that accumulated in the cups is pictured here as well. The setup with the lamp was able to move more water into the atmosphere under the plastic wrap, where it then condensed and rained downward into the cup. The one without the lamp was able to do that to some extent as well, but not nearly as much water accumulated in the cup. Keep in mind that the container was not completely in the dark, and even if it was, some evaporation would have taken place, since single water molecules do not require much kinetic energy to break free. Several things affect evaporation of water, including the amount of the water's surface area exposed to the air, the temperature of the water, and the relative humidity of the air. Both containers in this activity had the same water surface area, and they started with the same amount and temperature of water, and the relative humidity in the air under the plastic wrap at the start was also the same. The only difference was that the light energy from the lamp shining on the container heated the water in that container, which speeded up the process. So, did the light energy act as a pump moving the water within the system? Yes, it helps to speed up the process as well. If this is the case, then in nature, is the sun a pump? This is a diagram of the water cycle. In it, water evaporates and is carried into the atmosphere where it condenses. When the droplets get too large to remain in the atmosphere, gravity pulls them back to Earth as precipitation, where they accumulate and then are absorbed into the ground or become runoff. Then the cycle starts again. In short, the main processes involved in the water cycle are evaporation, condensation, precipitation, and accumulation. The sun provides the energy for evaporation to occur, fueling the cycle. Therefore, the sun is a pump, providing the energy needed for the water cycle to occur. Thank you for going through this EE Smarts lesson on the water cycle with me.